Hi, my name is Catherine Pfaff and I'm a math professor at Queen's University in Kingston, Ontario. And I'm going to continue on with, I've been going through a number of lessons on what I would call kind of functions boot camp, where I go through a variety of the different definitions and proof techniques and so on, having to do with functions that often students somehow or another don't pick up or get a little bit confused by or uncomfortable with. So we're just going to kind of jump into this. We've kind of gone through a number of these lessons now. So I want to go through function compositions and inverses. So we'll just start with function compositions. So one, function compositions. Okay, and then we're going to suppose that we have, okay, I'm going to have some kind of function. So let's get my function colors. I'm going to have f is going to go from s to t. And then I'm going to need a second function here, so I'm going to make that one, oh, I might have, okay. And then I'm going to have a second function, which is going to be g. And then this one's going to start at t, so this is the same t as this up there. And then it's going to go to a new, let's say it's going to go to u. Okay, like this. So suppose that these are functions. So we're going to suppose that these are functions. Remember, I sometimes abbreviate functions like that, where we have, so it's going to be crucial that we have that the domain of G is going to equal the codomain, which is, remember this, it's not necessarily this stuff we hit, because we don't necessarily hit all of it, but what we hit has to be in there. Okay. So this is where these kind of match up here, right? Then we say, so here's our definition. And this is function composition. Okay, so the composition of f and g so these are these f and g from above, like our functions. Okay, so I'm going to box this because this is what we're going to define. So the composition of f and g, and we have a way to write that, right? We usually would write that as, oops. I meant to do this in purple, so this is of f and g, because our g is purple. I have to say that the order, when we say the composition of f and g, I think sometimes people are a little sloppy. You actually kind of want to notate it like this so that we know what the order is. Okay, so we're talking about the composition of f and g. It's denoted like that. It's going to be the function, so it's a function. What kind of function is it? Well, we're going to tell you exactly kind of how it's defined. So what we're going to do is I'm going to take, I'm going to go, so, and this gets, people get a little weirded out by the order that these are in, but if you kind of look at how things are done here, right, it's going to make a little bit more sense. I'll point it out in a second when more is written out. So I'm going to go from S, so this S, and when I draw the picture in a moment, you might like it better. So this is this function. It's going to go from S, and then it's going to land in U. And my U is orange here. Okay, and what is it going to look like? So I'm going to send an element X, and I'm going to output for my element X that has to be an S, right? I'm going to output, well, what am I going to do to this X? First, I'm going to apply F, right? Which is why that F kind of needs to be written on that side so that it can be applied first. And then you can apply G like that. And so that's kind of the reason we write them in this order, even though a lot of people find it a little confusing. Okay, so in other words, right, so to kind of remember what this notation means, so this is, or in other words, so how do we define this? So G composed with F so if we apply this to a point X, we always are going to get out G of F of X, like this. Okay, so let's kind of draw this a little bit over here so that it'll help you keep track of what's going on. So I start out, right, so I'm going to start out with a function f that's going to go from s to t. So here's my s. I have a function f that goes like this, okay, and then I'm landing in t. Okay, so I start with an x over here, and in the first step, what happens? In the first step, it goes over to an f of x over here. So we can have an x, but now we've applied f to this, right? And then in the next step, now I'm applying g, and I've landed myself over in u, right? So g went from t to u, so I started where I left off from here, which was important. Okay, and now I'm going to apply g to this point. So f took me over from here to here, and then g is going to take me over to here. So now I get a point that's going to be g of, and then we put in this quantity here, so that's f of x. And then you could say that this function composition goes all the way, so that, right, that goes all the way from s to u, and we would say kind of factors through here. So this would be, this entire map would be our g composed with f, which might look a little funny again. Oops, f is blue. Again, that might look a little funny to us because first you apply f and then you apply g, but it's not that weird because first you apply f to x and then g kind of goes on the outside, so it actually does look like it's in that order. Okay? So, colloquially speaking, what I would say is first we apply f and then we apply g. Okay, smashing. So hopefully that made a little sense. That's how function compositions work. There's a trick to function compositions when you get trying to, make sure you're keeping everything straight and you don't want to get things confused. So let's just kind of go through an example. I'm going to erase all of this over here. Okay, here we go. Example. So if we have, so let's say we have this f. Let's bring all of our colors back over here because we're going to need colors. Okay, so I have a function f, which is going to go from r to r. I'm just going to write it all in blue here. And what it's going to do is it's going to send x to x squared. So this is the kind of function that you're used to, f of x equals x squared. And now I have a second one here. So I have a function g, which is also going to go from r to r. But now I'm going to send x to x plus 1. So again, this is a function like I'm used to, g of x equals x plus 1. Not a problem. And then the question is, what are these two? So what are g composed with f and f composed with g? Okay. And so what I would say is, and I'm actually going to kind of write this out because I think that this is really the key to doing this without messing up. It works for pre-calculus students, but it also works for math professors, okay, which is to take it one step at a time. and use parentheses carefully. And the parentheses carefully is a lot of it, in my opinion. So specifically what I do when I say that is I replace the variable with the parentheses, okay, and you'll see me do this. With the parentheses and then stick the input in. Okay? So here we go. So if we have, and we'll just do this over here. So let's start where we're going to have, I'm going to do G composed with F. So I'm going to go G composed with F of X. Right, and then we just remember from the definition, this is that I'm applying G to the whole thing of F of X. Okay, now we look at this and we're like, F of X, over here, okay. Right, I'm going to want to replace this F of X here. Well, what is that F of X? Well, that's F applied to X here, so I'm going to replace it with that. Okay, so this is going to equal G of, and then I'm just going to put in this X squared here. Okay. Now I have to keep track, well, what does G do? And this is where I say parentheses are very important. So I'm going to put this variable in, and so I'm going to replace over here, I have, it looks funny because they're the same, so I'm just going to replace that like this. Okay? And that kind of helps me to not get too confused, and actually, I think this is, I had some purple in here, and I want to put this back in because I think this might help a little bit to see that this is the function G. It's, I leave myself a blank plus a 1, and then in my blank I stick exactly that thing there. Okay? So that goes exactly into here. Right? And so what I get, and you might look at me and say that I'm being pedantic, but I think this is actually one of the things that I found is that it prevents a lot of mistakes just to do it this way. Okay, so then I'm going to end up getting that G composed with F of X is going to equal X squared plus 1. Like that. Okay? Now let's go the other way. Right, I just got that from there. So now I want to swap the two. So I want to put an F here and a G here. And then I'm going to put an X in here. Okay. So now, I just use this definition. So it tells me that this one goes on the outside, and this goes on the inside. Okay. And now I look and I say, okay, I can do this. This isn't too scary. I have a G of X here. I know what G of X is because I have over here that this is what G of X is, so I can just kind of replace that there. So I'm going to get F of, and I'm just replacing from over there, this is just X plus 1. Okay, and now I remember to write F, replacing my variable, which looks like an X here, and that's why it's going to get confusing, so I just replace it with parentheses. So I just replace that with parentheses. And then I stick in my X plus 1. Okay? Just like that. Okay, which happens to be what? X squared plus 2x plus 1. Okay, so I ultimately get F composed with G of X is going to equal that from over there. Now, there was a reason I expanded that out, and that's to notice that these are different, and that is totally okay. So note, G composed with F and F composed with G are different functions, and that does not mean I made a mistake. Okay? Great. Now, so that's how compositions work. And as I said before, the key, I'm a little bit out of here, but that's how compositions work. And as I said before, the key is really just the parentheses, and to do that very carefully. Okay. So now let's do function inverses. Okay, and there's a typo in the notes I'm going to need to fix, which is why I was staring at them for a moment. So we're going to suppose that F, again, always bring your colors to you. So suppose that F, so this is going to go from S to T. And the typo in here that I'm going to fix, so maybe by the time you see this, the notes will be fixed. Suppose this is bijective, is a bijective function. Okay? And in the notes, we talk some about why we want that. I'm not going to go into that in this particular video. Maybe I'll make a video at some point. But for now, you can look in the notes if you'd like. So function inverse. Okay, so the inverse of F is the function so we have F inverse, so we denote it like that. You've probably seen that before in your life. This does not mean we flip it over and take the reciprocal. This is a function inverse. Okay, so it's going to be the function. So this is also, I box this. Why do I box this? Because it's notation and I want that to stand out to you. Okay, defined by assigning so how do I take, okay, so I have an input that's in T. So how do I apply F inverse to this little t, which would be in T? Okay. So it's going to be the unique element in S so that we have that if I apply this F to this little s, I would get out T. Okay, so what does this kind of look? So hand waving, and then I'll kind of draw a picture. So first I don't know if you've heard mathematicians say that before. Physicists also like to say this. We wave our hands at something. It means that we're kind of explaining it with our hands all over the place. but maybe not in precise terms, but sometimes a hand-wavy explanation makes a lot of sense to us. So F inverse, it undoes whatever F did. Okay, so I get a picture like this. So I have a little S, and then this whole big thing. So I have a, this is my S here. And then over here, I have my T, living inside of my T, my green tea. Okay, and what happens is that F takes this S to T, and then my F inverse just does the opposite of that. So if S went to T, then it takes T back to S. So this is my F inverse, and this is my F. Okay? Now, that's my hand-waving, scribbly picture kind of thing of what's going on there. But let's say it concretely. Okay, we have that if I apply, so if I go, so I have this F inverse composed with, let's not have sloppy boardmanship, okay, and F. So if I apply this to some kind of S, I'm always going to get out S, no matter which element of S I choose. Okay. And in case this is a funny thing to you, this just means for all, or for each. I often prefer for each. That's often more precise. Okay. i.e., F inverse composed with F, right, is the identity function, the do nothing function. So it's the identity function on S, right? So it's a function that's defined to go from S to S, and what does it do? It always takes an element to itself. Okay. Great. So this has to be true, right? And the undoing has to happen, right? Because this kind of happens here, right? So if I go by F inverse, first I go by F. So I start with an S, I go by F, I get T, but then F inverse by definition takes that back to S. But I can also go in the other way. So F here composed with F inverse. Okay, and now we're inputting in a T, so we're inputting in an element of T, and in that circumstance we're going to get out that same element, and this works for all T and T. Think of that as like an A for all. Okay, i.e., right, what does this mean? This means that if I apply, so this function here, what is this function? It's the identity function, the function that fixes everything. Okay, so it's a function, I'm just using this to denote the function, the identity function on T, right? What does it do? It sends every element of T to itself. Okay, so then we get a picture that's kind of an expansion of that picture, which is, it looks like, it doesn't really matter how many elements I have in here. Maybe I have an S1 and an S2, and all the way up to maybe I have like an Sn, so maybe I have a finite number of points in here. Okay, and so this is my S. And over here I have my T. So now I have, again, so I have a finite number of points here, so I have a T1 and a T2, all the way up to a Tn, okay? And what happens is that S1, right, so F takes S1 to T1, so if this is true and it takes like this, and all of these go over and this goes like this, and then F inverse undoes each of these. Math is better with colors and sound effects. I promise. Okay. Right? That's just kind of the picture overall. You're just able to go back and forth, but you're able to go back and forth in either ways, right? Because this one, what does this one do? I start with T. If I go by F inverse over to S, then F has to take me back to T. Okay. So let's do an example. Okay, so if we have F goes from 1, 2, 3 goes to red, yellow, blue. Okay, and I'm going to define it by, you know what, I'm going to erase all this too so that I can just kind of do this all in one line. Okay, and this is defined by so we're going to have here, so we're going to say, okay, I just decided that I'm going to say that, I'm just going to do these all at the same time. So I'm switching colors left. So we're going to tell us what F of each of those are. So F of 1, I decided is blue. F of 2, I've decided is red. F of 3, I've decided is yellow. Okay, and we can draw that, right? So let's draw that. Okay, so this is my domain. Here's my codomain. This has to be bijective, so it's not a coincidence that these have the same number of elements when they're finite. Okay, and now I'm going to have, so I'm sending 1 to blue, and then I send 2 to red, and I send 3 to yellow. Okay, so this is what this function does. Now, how do I undo this function? Well, first off, it has to start there and go here. Okay, so I have F inverse is going to go from I have to go from red, yellow, blue. Back to 1, 2, 3. Okay, and how do I define this? Okay, so again, we do a whole bunch at the same time to the color just to save us time. Oops, these need to be bigger, don't they? Because I have words in them. So I have Here I have red, yellow, and blue. Okay, so how do I do this? Well, I have to kind of trace backwards, right? So I need to figure out, well, what goes to red, okay? What went to red was 2, so that has to be my output now. Now I want to figure out F inverse of yellow. So I look at what goes to yellow. What goes to yellow, I trace back, that's 3. Okay, and then I do the same thing here. I want F inverse of blue, so I look at blue, I look at what went to blue, and that was 1. Okay, so my picture now, it ends up kind of flopping it to go in the other direction now, so now I have 1, 2, and 3, and I have red, yellow, and blue. Okay, and then I can just look at this with purple, so it tells me that red goes to 2, red goes to 2. It tells me yellow goes to 3, yellow goes to 3, blue goes to 1, blue goes to 1. Et voila, I'm done. Okay. And that was everything I wanted to do with this. So I hope that that was useful, helpful, and that you will watch more of the videos. Also, I would recommend actually going through some of there's a variety of questions to go through. I call them a pre-quiz, but you can also do them after you look at the material to kind of check that you understand.